All right, so the reason we call it a unit circle is its radius is 1. And this will help us out in just a little bit. So what we're going to do is we're going to visualize a little bit. I have this unit circle here. So we're saying the radius of this circle is 1. So let me draw my center here. And I'll draw in the radius. And we're saying that r equals 1. And what we're going to visualize, the center of my circle here is at 0, 0. What we're going to do is visualize taking a number line and attaching it right here along the x-axis. So I'm going to take this number line and I'm going to extend it out like so. And it keeps going. And we're going to put 0, the point 0 on the number line right here at this point. So out on the number line I'd have 1, 2, etc. And what we're going to do is take this number line and we're going to wrap it around the unit circle. We're thinking of this number line as being flexible. We're going to take it and wrap it around the unit circle. So these points end up getting placed onto the unit circle. Every point on the number line is going to end up with a place on the unit circle. So I have a little animation that shows that to help us visualize this. So let's look at this one. Yes. So here's my unit circle. The blue is our unit circle. And the number line, we've taken the number line and I've stretched it straight up. And we're going to start wrapping this around the unit circle. So I'm going to wrap. And I'm going to stop there for now. We said the other day that when we're working in radians, that 1 radian is the arc length, gives us an arc length where the radius and the arc length are the same. And we said there are just over 6 radians in a circle. Well, our radius is 1, so every 1 unit is going to give us 1 radian. So here is 6 radians, 6 radiuses wrapped around that circle. So as I wrap this number line around the circle, each point on the number line gets laid down onto a point on the unit circle. And as I go around, the points just keep wrapping onto that unit circle. And I can keep going for as long as I want. So that's our idea, is we're taking that number line and wrapping it around. The reason we're doing this is we want to think about using trigonometry not just with angles, but with just numbers. So we're placing these points on our unit circle so we can associate them with an angle. Each one gets put in a particular place, so we can associate it with some angle on this circle. So we can think of using numbers rather than just angles. Is everybody good with the visual? That's kind of our starting place with the unit circle. All right, so let's go back. So we wrap that number line around, and as we wrap that number line around, I get points on my unit circle. And we can find the coordinates of the points because the center of our unit circle is at 0, 0. So we can associate each point on the unit circle with an angle. And we have points, the coordinates of those points on the unit circle based on that angle. And remember, we mentioned it as we were wrapping the unit circle. We said yesterday in radians, S equals r theta. Well, the radius equals 1 on the unit circle. So our arc length is associated with that angle. So we're associating a point on the unit circle, a point on the number line with an angle. Now, can everyone agree that as we move around this unit circle, these x and y coordinates are going to vary? They're going to change. Everybody agree with that? So I have another quick animation here that shows that. So here's a point on the unit circle. The red numbers are my x-coordinate, the y numbers are my y-coordinate. As I move around, those change. So x's and y's change as I move around the unit circle. So we're all good with that idea. Okay. So what we're going to do is we're going to say that the x-coordinate and the y-coordinate are a function of the angle. So because those x and y coordinates are varying, we say that the coordinates are a function of the angle. So x and y are functions of the angle. And we give those functions special names. X is the cosine of the angle. And y is the sine of the angle. So for the unit circle, this is really the big idea. Is on the unit circle, the x-coordinate of that point on the unit circle is given by the cosine of the angle. The y-coordinate is given by the sine of the angle. So anywhere on the unit circle, if we know the coordinates of the point, we know the cosine and the sine of the angle, because the cosine is the x-coordinate, the sine is the y-coordinate. And then we're going to use these functions to define some other functions. So I'm going to define the tangent of theta as y over x. The y-coordinate over the x-coordinate. We can also think of that as sine theta over cosine theta. The secant of theta is 1 over x. We can also think of that as 1 over cosine theta. The cosecant is 1 over y, and we can also think of that as 1 over the sine of the angle. And we will also define the cotangent as x over y, or cosine of theta over sine of theta. So for any point on the unit circle, the x-coordinate is the cosine of the angle that we're talking about. The y-coordinate is the sine of the angle. That's the big idea on the unit circle. We can define these other functions based on the sine and the cosine. What we're going to do is, on the sheet that I gave you, we're going to build some numbers onto our unit circle using what we know about special right triangles. Those special right triangles are going to let us figure out the sines and the cosines of various angles, tangents, cotangents, secants, cosecants, of various angles. We will know them, and we'll be able to have them in our memory. We won't have to use a calculator to figure them out because we know how the unit circle works. So let me grab a couple pictures here. So here is one page of your sheet there. And let me grab that. And then I'm going to grab, this is cross radian. I'm going to grab Radian, the snowman, and I'm going to put him next to that. So we're going to work on filling in both of these sheets using what we know about special right triangles. So on your sheet, our radius is 1. So we have these two special right triangles with the hypotenuse 1. So we can think of this as being a triangle, and the hypotenuse is 1. And we've been nice and labeled the sides of those special right triangles with their lengths because we know how special right triangles work. So let's start filling in this chart and start building our snowman. So over here, and the way that you usually see these is you'll put your angle on the outside. You can make it how you want, the way you can read it. So 0 radians. How many degrees is 0 radians? 0. Well, 0 degrees and 0 radians is this point over here. So this is 0 degrees, 0 radians. What are the coordinates of this point? If this is 0, 0. 1, 0. That's the coordinates of the point. The sine of 0 is the y coordinate. The cosine of 0 is the x coordinate. And then I can build the rest of these by using the sine and the cosine. The tangent is sine over cosine, 0. The cotangent, cosine over sine, 1 over 0. So that would be undefined. The secant is 1 over cosine, 1. The cosecant, 1 over sine, would be undefined. So on the unit circle, the sine of the angle is the y, the cosine is the x. So let's go to the next one. This is pi over 2, or 90 degrees. What are the coordinates of this point? 0, 1. The sine of pi over 2 is the y, is 1. The cosine is 0. And you can use those two to fill in the rest of your grid. Over here at this point, our angle is pi, or 90 degrees. What are the coordinates of that point? Negative 1, 0. And I wrote 90 degrees, this should be 180, sorry. The sine is the y, 0. The cosine is the x, negative 1. And I can use those to fill in the rest of these. Down here we have 3 pi over 2. And that is 270 degrees. What are the coordinates of this point? 0, negative 1. The sine is the y. The cosine is the x. And I can use those to fill in the rest of this. So now we have all of our quadrantal angles labeled, the angles for our coordinate axes. What I want to do is go through this first quadrant, labeling this first quadrant with you, and then your task is going to be to fill in the rest of the chart that's on the back with the rest of the angles and build your radian the snowman. Decorate them, make them look nice, make them a happy snowman. So let's start with this angle. And I'm going to draw this So what angle would this be? What is it? 45 degrees? In radians is pi over 4. So we have a 45, 45, 90 degree triangle here. So what are the x and the y coordinates? I'm looking over here. I'm going up how far? Square root of 2 over 2. I'm going over how far? Square root of 2 over 2. This side of the triangle is square root of 2 over 2. This side of the triangle is square root of 2 over 2. So the cosine of 45 degrees, or pi over 4, is square root of 2 over 2. The sine of 45 is the y, is square root of 2 over 2. So that goes in, you have a place for that on the back of your chart. And we're placing these special right triangles repeatedly onto my circle. So let's do this one in blue. So what angle would this one be? 30. In radians, pi over 6. The x-coordinate, what's the long side of the triangle? Square root of 3 over 2. And the short side? 1/2. And I have that right here. The long side square root of 3 over 2, the short side is 1/2. So the sine of 30 degrees, the sine of pi over 6, is 1/2. The cosine of 30 degrees, or pi over 6, is square root of 3 over 2. Let's do one more in the first quadrant in green. What would that angle be? That's our 60-degree angle. We're building these all with special right triangles. And in radians, pi over 3. And on this 30, 60, 90 triangle, the short side is 1/2, so the x is 1/2. The long side is square root of 3 over 2. So the sine of 60, the sine of pi over 3, is square root of 3 over 2. The cosine of 60, or the cosine of pi over 3, is 1/2. And then we can use the sines and the cosines to fill in the rest of the chart for those angles. So what you need to do as part of, so these sheets are, I'm not collecting these sheets are for you. These sheets are to help you remember to use as you're doing your work. As going through the process of building these sheets helps get these numbers into your brain. It helps you think about how the unit circle works. When I think of the cosine of 60 degrees, I picture that in my brain, I picture that point on the unit circle, and I picture that right triangle on the unit circle. And I think of the short side and the long side. That's how I remember what the sine and cosine of 60 degrees are. Is I think of this point on the unit circle, and I think of this triangle on the unit circle. That way I know I've gotten it right. So you want to fill in the rest of your 3 quadrants. You'll see that what happens is these numbers repeat, except for sign changes. And you'll have all of these angles made from your special right triangles laid out on your unit circle. And then you can decorate Radian the Snowman and lay your unit circle out on Radian the Snowman. There's a unit circle in your book. You can Google unit circles. You can Google Radian the Snowman and see these all filled out. But going through the process of filling it out is really going to help you understand how the unit circle works, how we can find the sines and cosines of these angles. And what we're going to end up doing on quizzes and tests is you are going to be doing your trigonometry without a calculator, without a unit circle. You will need to know this stuff. You'll need to know the sine of 30 degrees, the sine of pi over 6, the sine of 5 pi over 6, the cosine of 3 pi over 2, those kinds of things. You'll need to know that based on what you know about the unit circle. All right. So questions on this process, how we're building this unit circle. Okay, the big takeaway from today, the big thing that I want you to see for today is on the unit circle, the x-coordinate is the cosine of the angle, and the y-coordinate is the sine of the angle. That's the big takeaway from the unit circle. This is true on our unit circle. So complete your unit circle. All the homework questions today ask you about various questions about the unit circle, about x and y coordinates, about sines and cosines on the unit circle. And I'm changing the homework just slightly from the board. I'm leaving out problem number 2.